In an unconstrained optimization problem, when we have a function f of x, we optimize the function over all possible values of x. For example, in case we were trying to minimize x squared, we could have chosen any number for x, within the domain of the function. In the constrained optimization problem, however, we are trying to optimize the function f of x, for values of x, in some set S. The set of all possible points that satisfy the constraint is called the feasible set, and the individual points from this set are called the feasible points. For example, in case of minimizing x squared, if we were constrained to only using values of x that are greater or equal to 3, then any value less than 3 would not be feasible. And any value greater or equal to 3 would be feasible. While the solution to unconstrained minimization of x squared is x equals to 0, in our constrained problem, the solution would be x equals to 3. Let's now look at a sample of how the constrained optimization problem is usually presented. First, the problem states whether to maximize or minimize the function. In our example, we are told to maximize the function of two variables. What follows next are the constraints that the optimization is subject to. In our example, we have one equality constraint and two inequality constraints. According to the equality constraint, x and y should be such that the sum of their squared values should equal to 4. And based on the two inequality constraints, both variables should be greater or equal to 0.